Let's schedule CrossFit workouts using a very exciting form of artificial intelligence called Constraint Solvers. The Boolean Satisfiability problem, and its special case three satisfiability problem, was originally investigated by Cook in 1971, where he found that this is basically the original NP problem, and later Gary and Johnson described 3-SAT, among other NP problems, as basic problems within NP that if you can reduce any problem to those and solve it, then you've got the solution to all NP problems. Don Knuth describes the problem as such that you have a formula of n true or false variables, and these variables are expressed in clauses in the conjunctive normal form, where in 3-SAT, there's exactly 3 variables per clause. All the clauses are ANDed together, and the problem is, can you find some set of literal true-false assignments to the variables that satisfy the formula? And as an example, here you have a formula of 4 variables, A, B, C, and D, with only one clause. The clause is A or B or not C. The variable D is not actually used, so it could be true or false without impacting the truthhood or falsehood of the statement. And you just try to find some set of assignments that satisfies it. The problem looks easy, but it turns out it's solvable in brute force in exponential time. It's an NP-complete problem. And there are many SAT solvers out there that can solve this surprisingly fast. Minisat is an example of a program that can solve Boolean satisfiability. But encoding your problem in conjunctive normal form is pretty hard. So there's modern programs for constraint solving that allow you to type in your program in a much more intuitive way. Russell and Norvig in our textbook showed some problems that are solvable using a constraint solver. One was the map coloring problem. Another is Sudoku. And this is that makes constraint solvers very exciting. You can take a very hard problem, and maybe it's a problem you thought maybe was solvable with the greedy approach or dynamic programming, or maybe you just had no idea how to solve it and you tried to do it by brute force. Well, if you can model your problem for a constraint solver, then the constraint solver will have many, many heuristics to be able to solve that problem fast. And what you may end up with is a solvable problem. Even though you can prove that it's an NP problem, it may still be solvable. There are many commercial constraint solvers out there. C3, OR tools, and Choco are just some examples. So now let's talk about CrossFit. So CrossFit's a fitness program. It combines elements from many other disciplines. So you'll have your weightlifting and gymnastics movements, and also ordinary stuff like running and bicycling. When we want to model any problem in a constraint solver, we'll first need to model the variables. So for our CrossFit problem, we have a list of all movements that we could do and a list of all days that we're going to do them on. And we're going to take the Cartesian product of M and D and get V. So that's going to be lots and lots of variables. Those would be true, false variables. And every variable represents whether we're doing that movement on that day. Next, we add our constraints. So for first constraint, we're going to do at least 1 and at most 4 movements each day. Next, we'll have movements are never repeated. Movements are used at least once. All movements are used at least once. Third, movements are never repeated on consecutive days. And fourth, if a day has only 1 movement, then that movement is going to be one of running, swimming, or bicycling. This requires conditional implication, and we'll see that that's tricky. So here we go. This is going to be the table of true-false values that we're going to fill in. We've got a list of 9 exercises. We've got a list of 10 days. First, we're going to add 10 constraints that are going to say that we have at least 1 and at most 4 movements each day. This is, again, why you want to use a modern constraint solver and not an older SAT solver. SAT solvers, it would have been very difficult to encode your problem in this way using the conjunctive normal form. But with the modern sat solver, you get to, the modern constraint solver, you get to use things like summation in a way that often looks very much like what you're used to seeing in high-level languages like Python or Julia. Next, all movements are used at least once. This should be pretty easy. Most constraint solvers will have some built-in function like at least one or one of or exactly one of. Maybe you have, you could use the sum, or maybe you use Boolean or operation. That would work too. So which one should you use? Well, that is probably going to depend on your specific constraint solver that you're using. Some function may work better than another, and one thing that looks logically correct might not work at all. Next, movements are not repeated on consecutive days. So for this, we're going to need the not and operation. So given some movement I on days j and j plus 1, vij, and we're going to say not vij and vi plus 1j, which using De Morgan's law mean that it's a not vij or not vi plus 1j. Using rules like De Morgan's law is very useful, and when you're modeling a problem with a constraint solver, often you have to think about those things. You may also have a function like at most one. You may be concerned about adding so many constraints. I mean, that's quite a lot of constraints that we put on the screen, but think about your problem as a binary decision tree. And suppose that you're deep in the tree, you've been recursively trying to solve your problem, and now you've set some candidate solution to some position vij. Well, that means that now vi plus 1j and vi minus 1j, both of those are now constrained on the value. So those entire subtrees under your current position, those entire subtrees don't need to be explored at all. We've divided our problem. Every time we find a solution for one variable, we subtract, or we divide our problem into a quarter. And this is wonderful. When you've got an exponential time problem, being able to divide your problem quickly allows you to find a solution quickly. So in general, don't be shy about adding lots of constraints to a constraint solver. The machine actually thrives on having lots and lots of constraints that it can use to divide your problem quickly. Lastly, we have our problem of the monostructural movements, that if there's only one movement of the day, then that one movement must be the run, the swim, or the bike. Conditional implication can actually be difficult for constraint solvers, and we may need a separate variable. So in this case, we're going to create a separate variable. We'll just call it S. S is a statement. It's the statement A implies B. If the statement is true, then A and B both have to be true. If the statement is false, then that means A has to be false, but B can be true or false. So Google's OR Tools program has an only enforce if function, which you can use in this way. Now you might think, I should only use the statement S is true, then A is true and B is true. But you should also include if S is false, then B is false. And the reason why is to say, again, to help the machine cut down on the number of branches and speed up your program. Here we have a candidate solution. This output shown in front of you, this is a real output that's been modeled in Python using Google's OR tools. And you may notice that it's not really, if you've done CrossFit, you'll probably agree with me that this would not be a good program. Days 4, 8, and 10 are exactly the same, and those workouts really make no sense to do push-ups or sit-ups and pull-ups. This is kind of gets to the philosophy of using a constraint solver. The constraint solver is giving you a solution based on the constraints you gave it. Some constraint solvers will allow you to enumerate all possible solutions. And often you're using this constraint solver not to find a solution, but to prove that there is none. Either way, more information is better. So maybe you have some additional constraint that maybe not only do you, maybe you have to do one of squat, press, and deadlift every day or something like that. If you can say it out loud, then you can probably model it in your constraint solver. Lastly, Here are the references used in this paper. I hope that you've enjoyed this presentation on constraint solvers. It's a very exciting and powerful way for you to solve very, very hard, intractable hard problems on modern computers.